Let's think about what we've been doing so far. We started introducing elements to our language. We started off with simple things, basic objects, ways to do arithmetic operations on them, ways to compare them. We introduced conditionals as a consequence of that. And we started looking at the first version of ways to actually put things together into pieces of code. So we've covered language mechanisms. We've also covered the first notion of for and while loops and therefore of iteration. And we've also seen that we could write different kinds of computations, each one in a different file that I save away on my machine so I can use when I want to do something with it. Each file contains a piece of code, and each piece of code is some sequence of operations. It could be a simple branching program. It could be an iteration like a for loop or a while loop. It could be something else. This is fine when our code consists of a few lines. This is fine when our problems are very small. But it doesn't really scale very nicely. As I start thinking about pieces of code that might be hundreds or thousands of lines long, simply doing it this way is a real challenge. It's hard to keep track of the details. It's hard to make sure that I've got the right information in the right place in that code. Does this go at line 95 or at line 296? I need a way to really capture this better. I need a way of structuring my code, structuring my computation so that I can think about it much more efficiently. And that's what we're going to introduce now. One of the things to keep in mind is, in fact, good programming is more than just adding more code. In fact, I would argue that a good programmer is measured not by the number of lines of code she's written, but by the amount of functionality that she's provided, the ability to do computations easily. And so to make that happen, we're going to take a really nice pivot, introduce a major new thing, and that's the idea of a function. We're going to describe it in a second, but the idea of a function is it's going to give me a way to encapsulate pieces of computation. And in fact, a function is intended to give me two really important aspects of computational thinking: decomposition, sometimes also called modularity, and abstraction. So what do those mean? Let me give you an analogy, something a little bit different. I'm sure you've all seen a projector. I think of a projector as a black box. Now, the one I'm showing here happens to have a black box around it, but by black box, I literally mean a construct whose details I don't understand. In fact, most of us don't know what's inside it, how it actually works. If you open it up, you see a bunch of electronics, and unless you're a really good electrical engineer, you probably don't understand how it works. It doesn't matter, because you know the interface. You know the input-output behavior. And in fact, that black box comes with a standard interface that says if I plug an appropriate piece of electronics into it, that box can communicate with it, and it's going to produce an output. It's going to show slides on the wall. That's the notion of abstraction. It's the idea that once I've built something, in this case a projector, might be a piece of code, once I've built something, I don't need to know what's inside it as long as I know how it works. So abstraction in some sense comes with a contract that says if you give me appropriate inputs, I'm going to behave in an appropriate way. That's a really nice idea. That's something that we're going to want to use, and we're going to use it with code. There's a second piece to it, and we'll stick with the projector idea. If you happen to see the opening ceremonies for the Vancouver Olympics, there was a wonderful display in which there was a huge multi-story high structure in the middle of the rink onto which images were projected. Now, it wasn't one projector, it was way too big. It was a sequence of projectors. Each of them took an input, each of them produced an output, and they all worked together in synchrony to produce that wonderful larger image. That's the second big idea, decomposition. That I can, in this case, take different devices, have them synchronized so that they work together to achieve an end goal. I want to use the same thing with code. So we're going to apply those ideas to programming. Decomposition, I'm going to break a problem up into different self-contained pieces. And once I've built them, or even better, once somebody else has built one of them for me, all I need to know is what does it expect as input and what will the behavior be when it gives me an output. And the second big idea, abstraction, that I want to be able to suppress the details inside that method in order to be able to compute something using that computation. And in fact, I just said them in the wrong way. What I first described was really abstraction. Decomposition is that idea of breaking it up into smaller pieces. With those two things together, we're going to now look at how do we make programs have those two properties. Okay, inside of code, with decomposition, we're going to do the same thing we did when we talked about having multiple projectors working together. When I'm going to structure a big piece of code, I'm going to divide it up into modules. And those have the property that they're self-contained. That means they have everything they need inside of them. I'm going to use it to break the code up into pieces that I can separate apart. And they're intended to be reusable. I can use them multiple places. If you think about it, so far, even if I have a little file, I can only use it once. Or if I want to reuse it, I've got to go back and recall the file. Here I'm going to structure code so that I can use it in multiple places. And we're going to see that this idea of dividing code into modules is both going to keep the code organized and coherent. It's going to be easier to structure. Today we're going to do decomposition with functions. And in a few weeks' time, we're going to see how to do decomposition with classes. An equally powerful idea. We're going to suppress details with abstraction. Again, I said with the projector, I don't need to know what's inside, I just need to know what it does. In programming, we're also going to think of a piece of code as a black box. I don't need to see the details inside once I've written it, or especially if somebody else has written it for me. I, in fact, don't want to see the details inside. What I simply want to know is that it's going to work the way it was advertised. And we're going to achieve abstraction with something called a function specification or a docstring. And in a second, we're going to see examples of both of those. But there's the idea. Abstraction, decomposition. Two powerful ideas that we want to capture inside of computation. One of the things that comes out of this is not only do they work well together, but they can then be used many times. And in fact, not only can they be used many times, I only have to debug it once. It's one piece of code. If I want to make a change to it, I change that piece of code. Anything else that depends on that code will inherit that behavior because they simply depend on that code.